Hey guys, this is Dr. Mike Wuming. Welcome to another edition of Bootstrap MD. This is the podcast for physician and healthcare entrepreneurs. I've been saying for years, if you have a an idea, a product, a service that you think could be beneficial to mankind, you should be shouting out to the heavens. You just can't keep it on to yourself. And that's what happened with this couple. The company is called Imaginostics. It's a startup company. It was founded in 2018, where they're bringing to market a revolutionary longevity technology for early detection of diseases decades in advance through MRIs. The company's technology uses a new way to acquire data from existing MRI scanners and hardware, improving MRIs by 10x and enabling new physiologic measurements that describe the cellular vascular environment, representing a potential breakthrough for early detection of many age-related diseases, such as Alzheimer's disease and related dementia. It was founded by my following guests, a French-American couple who met in France in 2007, married in 2010, have two children. The physician, or the doctor, is Dr. Gharagouzloo, who's invented and developed a breakthrough quantitative imaging technology during his PhD in bioengineering at Northeastern University with postdoc research fellowship at Harvard-affiliated Massachusetts General Hospital in Boston. Valerie, his wife, was inspired Codi to launch a startup to bring his tech from bench to bedside. So that was my introduction for you folks, but I don't think I did it justice. I want to welcome to the program Dr. Codi and Valerie Gharagouzloo. How are you doing?
We're doing great. Thank you, Dr. Mike.
Yeah, fantastic. Thank you.
Thank you. Well, again, that was a mouthful. You have so many extraordinary achievements, but I want to hear it from you. And Dr. Codi, I'd like to start with you. Tell me about kind of your background and what kind of led you to this journey, in a journey that actually came out what you described as a faith, love, and science.
Yeah, so my background, my undergraduate's in physics and mechanical and nuclear engineering. So I've always been fascinated with nuclear physics. And at the same time, I've wanted to do something that helps people in healthcare. And so I got a master's in biophotonics, which is essentially imaging with light matter interactions, a lot of laser technologies. And, you can image, within a millimeter of tissue. It's mainly cellular work. So there's applications there. But I really wanted to get into medical imaging so we could get it to the human body. And then what I really noticed was among the different modalities that are available in medical imaging, MRI stands out as the modality that, can image inside the body, high resolution, soft tissue, right? But the sort of, longstanding drawback of MRI has been the qualitative nature of the imaging. So you get these images that are really appropriate for visual interpretation, but there are no numbers that quantify the physiology. So it's really more about looking at the individual level at anatomical details. And so I started out my PhD just reading papers 12 hours a day for 6 months and sort of theorized a new way to do MRI. And then I sat down at an MRI scanner and did a lot of small animal work for about 6 years. And so that's how I got started.
So, Valerie, how did you get into the picture here? And maybe tell us of your background.
Sure. So I'm a lawyer by background. I'm originally from France, followed Codi to the United States, went back to law school, became an attorney in New York. My background is more into international human rights, immigration. I was a lawyer entrepreneur with my own practice based in Boston, Massachusetts. So we've been married for more than 10 years. Codi spoke about his science like every single day. And it took me 6 years to understand the importance of this technology because it's, based on nuclear physics. It's very intensive, like scientifically. And when I understood that, I was like, this is amazing. I wish we had that at the hospital. So what inspired me to tell Codi we need to create a company. It was really like the desire to translate from the bench, from the lab to the bedside and bring it to people at the hospital.
Now, that journey, or the convincing a start of a company probably wasn't easy. Most in most PhD students who then become graduates, usually work for some big, expensive Fortune 500 company. You know, you said you were at the time just kind of working with some studies on animals. How did that transition? I mean, you had this idea. Was it like, should I tell my superiors about this? Is this something that they can integrate? Tell me about that process.
Yeah, so when I did my postdoc at Mass General Hospital for a couple of years, I transitioned from mice and rats to monkeys and humans. Still doing rat work, but especially in genetically modified models. But we by the end of my term there, we were able to get the first images of the human brain, and then so sort of demonstrated the proof of concept. We got these stunning images. And when my postdoctoral fellowship ended, we decided to, because of thanks to Valerie's courage here, we decided to have a startup. And fortunately, we were funded early on by physician investors. The leader of that group is an orthopedic surgeon that founded a hospital, and so that was really we couldn't have got started without that.
It's Dr. Mike too. Is the same name. Dr. Mike.
Another Dr. Mike.
Okay,
we
great.
have a lot of Mike supporters.
Oh, that's good. That's good. That's a good name to follow there.
But yeah,
So-
I think we were really blessed to have, the right type of support like early on, with angel investors, physicians who understood the importance of the technology for the medical field. And we were really blessed in that sense. And it was really early on, like I would say pre-seed almost, because Codi had to finish like his publications and, scientific publications. And he was still filing patents. So it was really early on. Yeah.
Yeah. So as you know, here at Bootstrap MD, we have our audience is filled with entrepreneurs who maybe started their business, or maybe going through that journey, and some have gone through that process of raising funds, getting their slide decks ready and presenting. How was that for you? Because it doesn't sound like, or maybe it does. Did you have a background in entrepreneurship with like family members or like?
I mean, well, Codi, you have all type of entrepreneurship, right? Codi started at 13 years old. He was parking cars in his yard. It was his first, and selling maybe sodas, as an
Earlier than
entrepreneur.
that, yeah, that's for the K-State home football game. So,
but I do want to say a special thanks to my law firm partner, Chase Liu, Attorney Chase Liu, because he really mentored us a lot. He's a business, lawyer, business consulting and business lawyer. And I think I learned so much from him as a lawyer, but as well, he mentored us a lot at the beginning when we started the company to understand all those things, like about founding a company and what you need to look for. And so, yeah, we had definitely his support and mentorship.
yeah, and I think, we were in Boston and Cambridge, Massachusetts. So we were in quite an innovation ecosystem at the Cambridge Innovation Center. So I was able to meet a lot of different founders and see what kind of technologies were being commercialized, what type of products people were commercializing. And, I really realized how important our technology was there, similar to, going to scientific conferences, right? So ISMRM is sort of the MRI conference. So I'm an MRI physicist. And, it was when I was starting to go to those conferences that I really realized how important that our technology was. And so I think similarly on the sort of, as an entrepreneur, kind of comparing, technologies, understanding the importance of it there in terms of commercialization, sort of a 0 to 1 technology, right? And quite paradigm shifting. So, kind of made me feel good and kind of reinforced the idea that, yeah, this needs to get out there. We have to commercialize this.
And we were part of like an ecosystem of entrepreneurship at the Impact Hub, at the CIC Cambridge in Boston. So every day we talk to entrepreneurs, and it was really, encouraging, very supportive and collaborative environment. So this really helped us to get started.
As a doctor, I wasn't used to asking for help, especially when it came to subjects outside of medicine. But then I found physiciancoaches.com. In an instant, I found hundreds of experts to help me in all aspects of life. On areas I was afraid to ask: dealing with burnout, starting a side gig, money management, even help with my marriage. And the best part? Nearly all experts are physicians themselves. After reading their profile and a quick chat, I knew I found the right mentor for me. At physiciancoaches.com, help from professional colleagues is just a click away.
So, there's the entrepreneurship journey, seems to be never ending. And I'd like again to kind of take you back to those early days. Where were you in the process of going out and seeking investors? Important term in entrepreneurship is having the MVP, right? The minimum viable product. But when you were going out to these investors, and you said you successfully got some, your early investors were mostly physicians. Where were you in the process? Did you already have it all kind of fleshed out? Was it still an idea, in your head? And maybe just talking about that, because if it's still an idea, it's kind of a difficult, no matter how persuasive you can be, for them to start putting their money where their mouth is. So maybe talk about those kind of early days, and maybe what was the one thing that led them to say, I really believe in what you're doing, Codi, and I want to be part of it.
Yeah, I mean, we had convincing biomarker data, that was published in small animals. We have those images and what they look like, and it's a really novel way to make vascular images, and they look incredible. And then because I was able to do the sort of first in human studies at Mass General Hospital, we had beautiful looking images of the brain. And so I think that's part of, sort of having that prototype, I think was critical to get the investment. And at the same time, that initial investment was really geared towards more prototyping, right? So we kind of had, one kind of working prototype to get some images, but now we need to sort of refine it. And so we took that money and went and worked with academic collaborators who, to sort of stretch the dollar as far as we could, right? So found the best in the field, started working with, Peter Larson, who's a professor at UCSF, that really, from ISM-RIM is where I met this guy, and he's an incredible imager. And so we worked there with him and went from alpha to beta versions. Later on, we licensed a specific sequence. So we have a whole sequence that we licensed from UW-Madison with another professor there. And so we had a MVP in mind, and we're essentially building it and raised the funds to build it. Yeah.
I also want to add is also the importance of relationships, we were introduced. So I think when investors, invest at such an early stage, they need to believe in the teams, they need to believe in the, in the founders. So, again, we were blessed to have, the introduction. I think relationships are fundamentals, because when you understand the person and, what drives them, and that they're not going to give up, they're really passionate about bringing this technology to the market. That's where, people are, not only believe in the technology, the potential, but as well in the strengths of the team to really achieve, the goals. So yeah, I think it was a good combination. I think there is a timing factor too. Things have evolved a lot in 5 years. But I remember when, Codi started to work on Alzheimer's research project. At that time, we had feedback from experts that didn't recognize the value of the vascular, aspect of the disease progression. This has evolved in the past 2 or 3 years, I guess. And now we do have the support, from experts in that field. So I think in terms of timing, how technology fits well with what we know in the field, in the medical field. and people understand, the value that it can bring. And just to add one more thing, one more thought for, to think about is that our goal is really to change the paradigm of care to switch from curative to preventative. So that's what we're working on, in terms of long-term vision. So it's really like a breakthrough platform technology that we're building.
Now, I think this would be a good opportunity to actually kind of dive into the technology. I think I listened to an interview you did talking about MRI and kind of the state of MRI, and I think, and then you can correct me. I think you said that it hasn't changed that much. It's still in the Stone Age. Maybe you want to elaborate and talk about how your technology is transforming and making a giant paradigm shift into what we're currently looking at.
Yeah.
And I want to add to your question that why MRI? Because Codi is actually an imaging expert. Why did you choose MRI for your PhD?
Yeah.
I mean, right. So again, okay. So in medical imaging, I mean, you really have a handful of modalities, right? You've got CT, which is great, but there's radiation exposure. You're not really, looking at tissue per se. You're looking more at like bone and high density things. You can use iodine contrast and you can try to get some information there, but it's not appropriate necessarily for interrogating soft tissue, right? You've got positron emission tomography, which is really great for quantification, femtomolar type sensitivity. But what you're really looking at there is, specific targeting of your agent to some moiety, right? And so if you want to look at an amyloid plaque or a tau, protein or something very specific, there's, nothing better than PET imaging. But if you want to characterize tissue sort of in a more abstract way, like, quantifying the vasculature of the tissue, it's not, quite appropriate. Ultrasound is great, but, limited in resolution. And so MRI just stands out, right? So that's sort of why I picked MRI. And then why I say that it's sort of not changed a lot is because, well, first of all, what I really care about is that you have a technology that a clinician can use and you get some useful information for that patient, right? And so far, what we see with MRI biomarkers is it works great at the group level. If you want to look at, for example, blood-brain barrier leakage, you can use gadolinium-based contrast agent imaging with DCE MRI, dynamic contrast enhanced MRI. You can see group-level statistics. You can see blood-brain barrier leakage. That's how we know now that, for example, people with mild cognitive impairment have blood-brain barrier leakage. Now, those there's fMRI. You can do all kinds of things. Some of it, doesn't necessarily have a direct physiological significance per se, like default mode network and so on. But even if you're doing like task-based fMRI, where, you have to have some repetitive tasks to get the signal out for, so it's just everything's sort of limited. You're not really able to get individual level significant results that are useful in the clinic. The one thing that I see that's, and even with arterial spin labeling, we're looking at blood flow. That's a powerful technique. But again, it's not quite sensitive enough to be used by clinicians. It's got a low SNR, long scan times, and again, errors in the inside of the brain, and you're just not able to get that individual level significant measurement, DTI, and so on. The one measurement that I've seen time and time again that sort of works is the size of brain regions, the anatomical delineation of brain regions. But by the time brain regions are sort of shrinking, I think that's a little bit too late. That significance for the individual level is like deep into Alzheimer's, but we want, let's say before somebody has cognitive impairment, you see something, right? And so that anatomical shrinking of brain regions is quite limited. You can look at vascular related features like white matter hyperintensities, right? So there's some ischemic burden there, but trying to use those, as biomarkers, they're moving around, they're changing in size. You can't quantify the ischemic burden. And so again, we're limited right now in MRI with for the individual level measurements for essentially just looking visually at these MRI images by a trained radiologist and picking things out, some kind of anatomical feature, maybe some kind of something that screams at you like a gross abnormality.
And I want to add that a lot of like the add-on on MRI or a lot of like AI company are developing out there to have a faster time of acquisition on the MRI machine, or to have like, maybe faster diagnosis. We differ from that because the technology is based on quantum physics. So it's a deep tech. And what's going to change is like the acquisition is different. So, Codi, do you want to explain a little bit?
Yeah, I mean, yeah, just so, everyone can be clear kind of what it is we're doing. So it's a different approach to imaging, much like arterial spin labeling or DTI or FLAIR imaging, all these different modalities that are used it's a different physical approach to data acquisition that gives you some different type of image in MRI. So we have QT MRI, which is quantitative, ultra short time to echo, contrast enhanced MRI. And it's another flavor of MRI. The objective of that imaging approach is to create essentially a 3D volume where the signal can be quantified by basic fundamental equations. So the spoiled gradient echo equation. So we get this quantitative sort of imaging signal in this volume of interest. And before, but then what we do is we enhance the vascular compartment with a contrast agent. We don't use gadolinium. For different reasons. One, it's sort of toxic, right? Now we know it accumulates in the brain of healthy people. It's not for preventative diagnostics. Also, it's got a short blood half-life, so it's being excreted sort of rapidly from the blood. And so we do use an iron supplement. So we use pheromoxytol. It's approved for iron anemia. It's been around for over 20 years. Now it's generically available. It's a nanoparticle formulation, so it stays inside the blood unless it's like very leaky, for example, blood-brain barrier. And so we can use that quantitative signal and that intravascular contrast to get these positive contrast images that are sort of very, very beautiful, higher resolution, better than these gadolinium images as judged by radiologists. And then quantify the partial volume of blood in each volume element that's filled with blood. So we can say, we see those beautiful vessels, but then also in those areas where it's just, 5% blood, we can say, is it 5% blood? Is it 6% blood? Should it be 6%? But now it's ischemic, and so it's 3%. So we quantify that. And then what we can do is we can use that quantitative measurement of, for example, the blood volume and do it in a functional way. So we can look at the vasodilatory response. And so we do that with a hypercapnic challenge. So, for example, the patient will breathe in 5% CO2, 95% air. That's going to make all the blood vessels dilate. And so we can measure those dynamics. We can measure the actual vascular reserve, which is essentially how much can those vessels dilate, because CO2 is such a potent vasodilator. And then we can put back on the air and look at the dynamics of things sort of coming back to normal. And so we can do the structure, which is the small vessel density, the function, which is those vascular dynamics, and the leakage, for example, blood-brain barrier leakage. So structure, function, and leakage. And so those are the type of quantitative measurements we make at the individual level at each voxel in space.
This has been great. So let's talk about, as you know, there are a lot of physicians who may be listening to this, anywhere from primary care physicians like myself, radiologists, neurologists. Let's talk about the clinical applications. We briefly discussed about like Alzheimer's disease and more as a tool, and you're evaluating in terms of prevention. Let's discuss this. What are the clinical applications of your technology?
Yeah, so Alzheimer's disease is sort of near and dear to my heart, right? So I was, for example, the co-chair of the Alzheimer's Association Business Consortium for a couple of years. Just finished that term. A lot of my research has been in neurology, especially in genetically modified animals for Alzheimer's disease. So in terms of early detection, what we've seen in the small animals, for example, on an APOE4 genetically knock-in animal model, was that very early on, before there's any manifestation of cognitive impairment, for example, a 20-year-old human equivalent in these APOE4 genetically modified rats, we see increases in small vessel density, right? So with neurodegenerative disease, you think you're going to find some decrease in the small vessel density. You're going to get, all that brain shrinking and things, but all that happens much later on. So we were able to map out with super high significance, right, individual level stuff, that early on in more than half of the brain of these animals, they've got an increase in small vessel density. So that means that there's some kind of chronic problem that the brain is now compensating for that metabolic dysfunction by doing that. And then
we have applications in neurology. So like, Alzheimer's is one, Parkinson's, stroke, like rare disease as well. Like, so like a lot of application in neurology, but not limited to neurology, because the technology will work in any type, in all the organs. So there are application in cardiology as well, the application in cancer, for inflammation as well. And we can also image in and around stainless steel vascular implant as well. So what we've been doing is that we've been as well applying for grants as non-dilutive equity funding to pursue those different applications. It takes a lot of time because we have to develop collaborations, with different hospitals, with different experts, apply for funding. So right now we're more like developed in the Alzheimer's, sector, but the idea is to have, to develop all those applications. Traumatic brain injuries as well is one of the applications. It's really like a longevity technology in the sense that it's, in terms of impact, it has a lot of different applications in neurology, cancer, cardiology, and other, disease. But because we're able to detect, change in the vasculature, the idea is to really detect disease decades in advance. So what one of the reasons why actually we relocated to Orlando is to work with a leader in preventative diagnostics. So it's a private clinic. And the idea is to offer full body MRI scans, with how technology. They also use different type of techniques, and between, blood biomarkers, how technology, different AI, see if, how we can help to detect disease, so if that you might have a stroke, then you go to see your doctor and, see if there are things that you can implement to stay healthy, So the idea is really to help, change medical care where people will be able to see the doctor maybe in their 20s, and detect those diseases decades in advance. So they go see the doctor, but not when they are sick, really when to have a preventative treatment plan, Yeah. And we believe that we can achieve that. So in a way, we are a piece of the puzzle of longevity, because we can help with those really advanced diagnostic at the individual level for precision medicine, but we can also help, the pharma, biotechs, with how endpoints to measure the efficacy of their novel drugs, especially anti-aging drugs.
Right. So, yeah, go ahead.
It's so those are the sort of the vision and sort of long-term play, right? And so, we do have biomarkers of aging, and if there's any, deviation in the vascular structure, function, or leakage, such as in Alzheimer's, or other diseases, we can see that. In the short term, so now we finally have opened up a regulatory pathway by working with, some of these big MRI manufacturers. And so now we can get our pulse sequence software cleared. And then we're bringing to market our vascular imaging solution. It'll be available within a couple of years. And so then it'll be everywhere. And so first we're, because there's the 10x better MRI and there's all those precision medicine imaging biomarkers for all these diseases. So we're raising money to go to market with just the vascular imaging technology, and focusing in on patients who are contraindicated to gadolinium. So every year there's 40 million MRI scans in the US, 20 million with gadolinium. And patients who have chronic kidney disease, if they have CKD stage 4 or 5, they're absolutely contraindicated to gadolinium. But if they, the 37 million Americans who have CKD, it'd be better as well if they, didn't get the gadolinium, even if they have stages 1 to 3. And so we know that there's at least 1 million scans that are not undergone because of contraindication and concern for, nephrogenic systemic fibrosis and these type of things. So we want to first start into that market and then sort of open up into the more, larger market sort of, for anybody who doesn't want gadolinium, because it is a 10x better scan. So that's sort of our go-to-market is just the vascular imaging solution. The second part of our business model, if I can, should I share that? Is
Yeah.
I mean, but
We can provide more information.
we can
to
provide
people
more
who are interested.
information.
Yeah.
But we have a really excellent strategy here and excellent partners as well. And then that's that sort of 2-year approach, right? Just the vascular imaging solution and sort of getting into beachhead markets and expanding. And then in parallel, again, we're going after these biomarker-based solutions through non-dilutive funding. And that will be, in the future, our focus where we really expanded it, really even larger markets. If somebody gets hit in the head, they got a concussion, a TBI, you got suspected, cognitive impairment. There's so many different applications then in really huge markets with unmet needs that we're following up even now through non-dilutive funding. Yeah.
Yeah, this is really exciting. And just talking about, just going back to your example about, Alzheimer's, right? They were having cognitive decline. And yes, the MRI shows that there is a decrease in brain matter, but then what are you going to do? So we know that in Alzheimer's, there is abnormal blood, vasculature. And that's probably the time to start really having early intervention versus just like seeing it. So, and again, with your example of the gadolinium, effects on renal vasculature and chronic kidney disease, obviously there is millions of people who are do not have the ability to use that. So very exciting. And again, you shared us all the different conditions. For those who are listening to this and maybe they're looking to learn more about your company, perhaps maybe interested in maybe investing, as you had mentioned that as well. What's the best place where they can go and find out more about Imaginostics?
Yeah, so we've got Imaginostics.com. So that's the website. You can email me at Codi, CODI, at Imaginostics.com, and Valerie, VALERIE, at Imaginostics.com. You can reach out to us on LinkedIn as well. We're sort of active there.
And just Imaginostics stands for imaging diagnostics.
Imaging plus diagnostics. I know, like the imagine is kind of fun because imagination, but it's that's just a bonus. I think it's imaging plus diagnostics. So.
I love the name. I love the name. Codi and Valerie, again, it's been a pleasure to learn about you, to meet you, and learn more about your technology. Maybe if you give us like one last advice to maybe the entrepreneur or the wantrepreneur out there who's in healthcare, who's got an idea, maybe had seen some things that they're currently doing and wants to move forward, but they're not quite sure. Any advice for that person?
For me, I mean, like reach out, like talk to people, find your tribe. That's my best advice. And it took us a long time actually, because, we didn't really know how to define ourselves. So we understood that we were deep tech, compared to like, just digital health, or we're not as well a medtech because we don't have any hardware. We're not a biotech because we don't propose, therapeutics. We help biotech with their therapeutics. But yeah, we, after we understood like we are deep tech, we are longevity tech, we reach out to the different, ecosystem. And I'll say, don't stay isolated, like join a program, an incubator, just get started and make some connections. And I know that there are some programs as well where they match you with potential co-founders. So like if you're a physician and you want to, match with someone with a background in business or computer science, go to those like events and, ecosystem events, because that's how you're going to meet, your ideal team and co-founders.
Wonderful. Codi, any words from you?
No, I think Valerie's amazing. I think that's right. I think it's more about who. Yeah.
One last, maybe a shout out for Ido's program.
So I mean, there are some, there are some programs such as, I was in Ido Tal's program called Raise the Round, right? Yeah. And there's all kinds of different entrepreneurs in there, and they teach you, how to build the deck, how to reach out to people, how, what do you say? So from A to Z sort of in fundraising. And so there are places to learn those skills, and they are skills. And,
Yeah.
and you need some kind of crash course on it. So I would definitely recommend Ito's Raise the Round course. I thought that was really helpful. Plus, you start to meet other entrepreneurs in there as well.
Yeah.
And it's really, and maybe that was the most important thing from that group for me, was just the people themselves and the
And
encouragement. Yeah.
there was a Facebook group, a WhatsApp group. And I remember when we got started, it was so hard to explain the technology in 10 seconds, you know? So Ido is the one who said, but you know, you have a deep tech platform technology. It will take more than 10 seconds for you because sometimes you have, you know, expectation from what people tell you. But it's not applying to you. You might be the exception compared to the rule. And we learned that with Ido, you know? Yeah.
Oh, wonderful. And then I might add too, it does help that you're in a area. I mean, I know with Zoom and everything, we're getting connected, but it does help that you're in an area where, startups are around. You've got entrepreneurship. I was in an incubator here in San Diego as well. And it's kind of being around, to be able to network and learn from these folks
Yeah.
that you had mentioned that as well.
And we
So,
moved to an area as well with has, you know, it's like a health cluster here in Lake Nona Medical City. We co-working members of the Gadwell Innovation Centers. So it's really, you know, they always organize conference about the health sector, you know, the future of health. So we actually took when we started, we took a picture we posted on LinkedIn, and behind on the background is like reimagining the future of health. I mean, you know, we come to work and we know what, you know, that really remind us, you know, what we are working for, you know. And so I think, you know, finding your tribe, you know, whether it's your office space, co-working space, or a virtual group, it's really important.
well, Dr. Codi and Valerie, thank you again. Imaginostics, well, we'll put out the links. If anybody wants to reach out to you, we'll have that in the show notes as well. Thank you for your time. We'll let you get back to the lab, back to work, and keep fighting the good fight.
Thank you so
Thanks.
much.
And thank you for listening. As always, as entrepreneurs, you can have your ups and downs. Do something little each day to get you closer to your goals and keep moving forward.